Hi everyone. Today, we're diving into a specific error message you might encounter on the Ethereum blockchain: invalid opcode 0x5f not defined. It sounds technical, but don't worry, we'll break it down into simple terms so you can understand what it means and why it happens. This error is a clear sign that something isn't quite right with a smart contract or a transaction. First, let's understand some basics. Ethereum runs on something called the Ethereum Virtual Machine, or EVM. Think of the EVM as the brain or computer that executes all smart contracts and transactions on the network. When you write a smart contract in a language like Solidity, it gets compiled into bytecode. This bytecode is a series of low-level instructions that the EVM can understand and execute. These individual instructions are called opcodes. Each opcode has a specific numerical code. For example, there's an opcode for adding numbers, another for subtracting, one for storing data, and so on. They are the fundamental building blocks of any operation on Ethereum. So, what does invalid opcode mean? It simply means the EVM encountered an instruction, or opcode, that it doesn't recognize or that isn't part of its defined instruction set. It's like telling your regular computer to run a command it doesn't know how to process. When the error specifically says opcode 0x5f not defined, it's pointing to a very particular instruction that the EVM found. The 0x5f is just the hexadecimal representation of that specific unrecognized opcode. It's not a special number, it's simply the identifier for that particular invalid instruction. There are a few common reasons why the EVM might encounter an invalid opcode. One primary cause is a malformed or incorrectly compiled smart contract. Sometimes, a contract might have been compiled using an outdated compiler version, or perhaps there was an error during the compilation process itself. This can result in the generated bytecode containing instructions that the current EVM version doesn't support or understand. Another reason could be a deployment error. If the smart contract code wasn't deployed correctly, or if there was a data corruption during the deployment process, the EVM might receive and try to execute garbled or incorrect instructions. It's also possible, though less common, that a transaction is accidentally trying to execute data that was never intended to be code, leading the EVM to interpret random bytes as invalid opcodes. Rarely, bugs in the smart contract compiler or development tools could also generate erroneous bytecode, which then leads to this error. When you see this error, what does it mean for you? Most importantly, any transaction attempting to execute this invalid code will fail. This means your transaction won't go through, and unfortunately, you will still lose the gas fees you paid for that failed transaction. If a deployed smart contract contains this issue, it simply won't function correctly at the point where the invalid opcode is encountered, making the contract unusable for its intended purpose. To avoid or fix this, there are several steps you can take. Always ensure you are using the latest stable versions of your smart contract compilers, like Solidity. Thoroughly test your smart contracts on testnets before deploying them to the main Ethereum network. This allows you to catch these kinds of errors without losing real funds. If you're developing, use robust debugging tools that can step through the EVM's execution of your bytecode. These tools can pinpoint the exact line or instruction where the invalid opcode occurs, making it much easier to diagnose and fix the problem. Additionally, always verify the deployed contract code on block explorers like Etherscan to ensure what you deployed is exactly what you intended. In summary, an invalid opcode 0x5f not defined error means the Ethereum Virtual Machine encountered an instruction it doesn't recognize. It's usually a sign of bad or incorrectly compiled smart contract code, a deployment error, or an issue with the tools used to create the contract. By using up-to-date tools, rigorous testing, and careful deployment, you can largely prevent these frustrating errors. If you found this explanation helpful, please give this video a like. It really helps us out. And don't forget to subscribe for more easy-to-understand explanations of complex blockchain topics. We'll see you next time.